Hi everyone, my name is Phoebe. So today I'll be introducing a really interesting mathematical concept that is basically ubiquitous in our everyday life, which is combination. What is combination? So combination is a mathematical technique that determines the number of possible arrangement in a collection of items where the order of the selection does not matter. So what I meant by that is, for example, if I have 5 balls over here and which each has a distinct number on them from 1 to 5, then if I want to determine how many ways that I can randomly choose 2 balls from these 5, then I may use combination. But just note that it doesn't matter whether I choose, such as if I just want to choose 1 and 2 from these 5, then it doesn't matter whether I choose the ball 2 first or ball 1 first, because it ends up that they're the same group. So from here, what we're just really into determine is that how many ways that we can choose 2 balls from 5 of them. So here we have a really rigorous mathematical formula for this, which is 5C2, which stands for the 5 combination of 2. So how we calculate this is that, so until here, so what we just really need to find out is the number of ways that we can choose 2 balls from the 5 of them. So here we have a really rigorous mathematical formula to express what we want to find out, which is 5C2. So this stands for the 5 combination of 2, and how we calculate this is that NCR is n factorial over r factorial bracket n minus r factorial. So that's our formula for combination in general. So now we know that in this case n is 5 and r is 2. So we basically just plug in numbers. So n is 5, so here is 5 factorial over 2 factorial bracket 5 minus 2 n factorial. So this basically equals to 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 factorial, which equals to, so here we can cancel these two, and so which equals to 5 times 4 times 3 times 1 over 3 times 2 times 1. So here we cancel 3 and 1, and here this becomes 2, which is 10. So it ends up that we have 10 ways to choose 2 balls randomly from the 5. So from the really simple question that we just did, we basically went over the rudimentary concept of combination. So now I still have a few questions. I promise that they're really understandable, and let's just go over all of them. So question 1, 5 boys and 5 girls were nominated for a homecoming celebration at a local school. How many ways can the king, queen, and court of 2 students be selected from those nominated? Assume that king must be a boy and queen must be a girl. Okay, so first we know that there are in total 10 kids, but the condition is that the king that they chose must be a boy and the queen that they chose must be a girl. So let's first consider the king. So the king, so we know that we can have 5 different choices for the king because we have 5 boys. And So the choices for a queen is also 5 because we also have 5 girls. So, and for the courts, it's a bit harder because like the 2 court people can be just like any 2 random people from it, and regardless of their genders, I mean. So like it's basically that we need to choose 2 people from the rest. So like that's basically we need to choose 2 people from 10 minus 2 because the king and the queen cannot be involved in that selection. So that's 10 minus 2 C2, which is 8C2. And according to the formula that we just used, this should be 28. So in total, the number of ways of this selection should be 5 times 5 times 28, which is 700 ways. Alright, the next question. A committee consists of 10 people. How many ways can a subcommittee of 3 people be selected from the committee? How many ways can an executive subcommittee consisting of 3 people, chairperson, treasurer, and secretary, be selected from the committee? And so the first thing that we all notice is that we have 2 sub-questions in this large question, and also we notice that like the first question is actually super duper easy. It basically just means that how many ways that we can choose 3 things from 10. So that's basically 10C3. They're really rudimentary concept that we just went over. So this is 120 ways. Okay. And for question B, it's a little bit tougher than it's not only the pure combinatorics that we just went over, but also like it's a little bit related to permutation and just in general probability. So like obviously in this case, the order actually does matter because the 3 different jobs represent different things. So if I just let person A like to be a chairperson, it's actually different from I to let a chairperson to be a treasurer or secretary. Okay, so in this case, what we need to do in order to solve this problem is that let's just pretend that chairperson is the first line, treasurer is the second line, and the secretary is the third line. So we know that for the first job, which is the chairperson, we have 10 people to choose from, right? Because just everyone has the right or possibility to be elected, right? And the second job, which is the treasurer, we only have 9 people left, so that's 9. And for the last one, secretary, we only have 8 people left, so that's 8. So that's how many ways that we can choose them. So we just multiply them together, and this equals to 720 ways. Okay, solved. So here we have our last question in this video. On May 17, 1998, a Powerball lottery in Oregon had a main jackpot of $195 million US. In this lottery, participants choose 5 numbers from 1 to 49 and 1 number from 1 to 42. Question 8. How many different ways are there to choose the numbers? Question B. What is the probability that all 6 numbers chosen are drawn in the lottery? So for question A, we know that, so we will get a number of ways that we can choose 5 numbers from 1 to 49. Let's just let that number be A. And a probability or number of ways that we can choose one number from 1 to 42. Let's just make it B. And we multiply them together to get the final ways of choosing those numbers. So let's first calculate A. This is for question A. So A is randomly choose 5 numbers from 49. So that's basically 49C5. And this times randomly choosing one number from 1 to 42. So that should be 42C1, which is basically 42. So after, okay, this should be this. So after calculating each of them, we multiply them together. We can just first multiply them together and just directly get a final result. Doesn't really matter. So that's AB should be this number. Which is 80,089,128 number of ways. Okay. And for question B, what is the probability that all 6 numbers chosen are drawn in the lottery? So in order to calculate this question, so we need this number from the previous question. So we know that there are only one combination of all of those number of ways is correct. So that just simply should be 1 over this number that we got from question A. So that's our final answer. Okay?